Okay, let's dive into this. Welcome to today's explainer. We are looking at a sleek, highly futuristic vision of the absolute cutting edge of network tech, intelligent broadband. Today we're exploring exactly how 5G fixed wireless access and these massive bidirectional edge AI data streams are fundamentally rewiring how our world connects. It's a whole new ballgame, so let's get into it.
210 exabytes. Just let that sink in for a second. According to the latest Ericsson Mobility Report, that's the total global mobile network data traffic we are projecting for just the first quarter of 2026 alone, right? Just one quarter. To put that insane scale into perspective, we were hovering around 30 exabytes just a few years ago. We are consuming data at a scale that legacy networks, well, they literally just weren't built to handle.
But here's where the story gets a little tricky. If you look at year-on-year mobile traffic growth, it actually looks like it's leveled off. Like 7 years ago, growth was absolutely exploding at over 80%. But in Q1 of 2026, it flattens out to 22%. So are our data demands finally stabilizing? Are we taking a breather? Well, not quite. This apparent plateau is kind of a mirage. It's actually masking a massive underlying shift in the very type of traffic flooding the network.
And that brings us to what Ericsson calls the dark horse of network growth. While traditional mobile phone growth might be finding its ceiling, there's a silent giant responsible for a totally new era of data consumption: fixed wireless access, or FWA. It's rapidly connecting suburban homes and smart industrial hubs with high-speed internet, completely bypassing physical cables. And honestly, it is fundamentally changing the math for network operators.
Consider this completely staggering figure: 500 gigabytes. That is the average monthly data usage for just a single fixed wireless access connection. Think about that. When an operator sees even a tiny 1 or 2% bump in FWS subscriptions, the impact on the network is the equivalent of adding 10 to 20% more mobile phones. It is an incredibly heavy load on the infrastructure.
To really understand that burden, just look at standard smartphone usage. We're talking a mere 25 gigabytes a month. So compare that 25 gigs to the 500 gigs required for FWA. It's night and day. We aren't just scrolling social media on these FWA connections. We're powering whole smart homes, running complex enterprise applications, and just constantly streaming high-definition media.
And this demand, it's only going to build. Global FWA subscriptions are projected to absolutely explode, going from 185 million connections in 2025 all the way up to 291 million by 2031. And the crucial part here is that 5G will account for more than half of all those global connections by 2029. To actually deliver these broadband services, operators are going all in, relying heavily on mid-band and mmWave 5G networks.
So, the big question: how do you handle this massive surge without completely breaking the network? Well, it all comes down to some highly sophisticated hardware at the edge. Operators aren't necessarily building new sites just for FWA. Instead, they're upgrading their existing sites to handle both mobile broadband and FWA at the same time. They're basically offering a converged service through these sleek, glowing 5G CPE routers that act as our modern connectivity hubs.
Which brings us to the actual engine of this high-capacity wireless revolution, VectaStar NR. Developed by CB&G, this is a next-generation 5G mmWave point-to-multipoint access technology. It operates over licensed spectrum specifically designed to deliver high-capacity, low-latency broadband. The really cool part: its coreless architecture requires minimal infrastructure dependency. That gives operators the exceptional scalability they are desperate for to offload these congested networks.
And the carrier-grade specs behind this thing are genuinely impressive. First, it utilizes cognitive multi-beam forming, basically phased array antennas with fast switching that intelligently adapt to dynamic conditions on the fly. Second, it features a native embedded 5G core, completely eliminating the need for an external radio access network core. Throw in up to 6.5 gigabits per second throughput per sector and ultra-low latency, and you are flawlessly delivering fiber-like performance straight over the air.
Now, everything we've talked about so far, the massive capacity, the incredible hardware, it's really just setting the stage for an even bigger shift. I'm talking about the AI uplink revolution. Historically, data streams flowed mostly in one direction, right, down to the user. But Edge AI is causing this massive uplink flip. Suddenly, we have heavy data traveling aggressively in the opposite direction.
Think about it. Legacy networks were designed to be downlink dominant. Their main job was feeding us video streams and web pages. But these new AI networks, they are uplink intensive. The focus has completely shifted to continuous sensor data and real-time video uploads.
Actually, Ericsson found that in 2025, more than 3/4 of operators experienced higher growth in uplink traffic than they did in downlink. That is a massive paradigm shift.
So why exactly is the uplink becoming the new bottleneck? 2 letters: AI. Wearables, phones, enterprise sensors, they are continuously scanning our environments and pushing high-definition video uploads straight to the cloud for analysis. Now, if a device processes data locally, sure, the network impact is pretty small. But if it's constantly pinging the network, feeding massive files to AI agents for cloud processing, the traffic increase is astronomical.
Peter Linder over at Ericsson has this brilliant analogy for what's happening. He says, mission-critical AI workloads are like first responder vehicles with flashing lights. I love that. When an enterprise sensor spots an anomaly and sends real-time video to an AI agent for immediate analysis, you literally cannot delay that data. A 10-minute downtime? That could be disastrous. The network absolutely has to treat this traffic with the utmost urgency.
Because this heavy AI uplink data is now out there competing with everyday traffic, like someone's social media post, operators have to take 3 essential steps. First up, the network actually has to use AI itself to automatically recognize incoming AI traffic. Second, it has to immediately prioritize that mission-critical data. And third, it has to temporarily slow down the non-essential traffic to clear the lane. Just like cars pulling over for an ambulance, the network automatically makes way.
All of this brings us to the intelligent broadband future. We are way past just talking about faster download speeds. This is a highly unified, high-tech ecosystem. The 500 GB demands of FWA, the deployment of 5G mmWave gear like VectaStar NR, and this exploding edge AI revolution requiring prioritized uplink, they're all deeply interconnected. Operators have to carefully dimension their networks to handle this incredibly complex, bidirectional web of traffic.
So, I'm going to leave you with this final thought. Networks designed strictly for downlink consumption, they are officially a thing of the past. As AI turns every single phone, wearable, and industrial sensor into a continuous, heavy-duty uplink engine, the whole paradigm has shifted. The future of connectivity is intelligent, it's bidirectional, and it's incredibly demanding. The only question left is your network ready? Thanks for joining me on this explainer, and keep your eyes on the horizon.